Okay, so today I'm going to cover this quick KP question. Now, this is from the AQA example, but this is very similar to a kind of question you get in a Wjec A-level exam. So we're going to go straight into it. So we're told phosphorus pentachloride dissociates at high temperatures according to the equation of PCl5 goes to PCl3 and Cl2. We're told that 83.4 grams of the phosphorus 5 chloride are placed in a vessel of 9.23 decimeter cubed, and at equilibrium it's a constant pressure, and 11.1 grams of chlorine produced at a total pressure of 250 kilopascals. Answer the questions. Okay. So I always like to rewrite the question because you can kind of modify it throughout them if you need to. Okay, so we're now told to calculate the number of moles of each of the gases present at equilibrium. So we'll start with chlorine because we'll start with our reactants and then, or our products, and then go over to reactants is my way. So we're told that 11.1 over 71 because that's the molar ratio, and this is going to equal 0.156. Now we're told this is in a 1:1 ratio, so this must mean that there's also 0.156 moles of product of PCl3. Now the PCl5 is a bit different. So PCl5, we're told we have 83.4 grams. Divide that by 5 times 35.5 plus 31, which is going to be something about 208 mark. So 83.4 over 5 times 35.5 plus 31 gives you 2 over 5, which equals 0.4. Now we're told that's at the start of equilibrium, so we actually have to subtract this, because if you remember from one of my videos on my YouTube channel, we have to create a table. So I'll do that now because we might need it further on in the question. So we got moles, we got start, we got the change, which I write as delta, and then we got the equilibrium. So the moles of PCl5, PCl3, Cl2. So we're told at the start we have 0.4, we must have 0 of them, 0 of them. The change is plus 0.156, plus 0.156. Change in this must mean minus 0.156. So this is going to equal 0.244. And this will be 0.156, 0.156. Okay, so that will come in handy towards the end, I reckon. Okay, so that's the number of moles of each of thingies. That's question A answered. So now B is asking to write an expression for the equilibrium constant Kc. So remember, Kc is the products of reactants. So products are going to be PCl5. Now remember, for Kc you have to do it in square brackets. Cl2 all over. Oh no, PCl5. A little mistake there. That's going to be a 3. Boom. Now I'm guessing it's going to ask to make Kc. Yeah, calculate the value of Kc in equilibrium. So Kc, remember, is our concentration. So at the moment up here we've got is moles. So we need to convert this into concentration values. So we need to remember that number of moles over volume is equal to concentration. So for these two here, it's going to be 0.156 divided by the 9.23 decimeters we are told. 0.156 divided by 9.23 equals 0.017 mole per decimeter cubed. So that's for PCl3 and PCl2. Now for PCl5, it's going to be 0.244 divided by 9.23. So it's 0.244 over 9.23 is equal to 0.026 mole per decimeter cubed. So we can write this now as 0.017 squared all over 0.026. 0.017 all squared, divide that by 0.026. We get an answer of Kc being 0.0111. Now that's telling us that our products, we have a low product value. Okay, so that's Kc. Now they probably wanted units for that. And it's simply going to be mole to the minus 1 dm cubed, because we've got mole squared dm to minus 6 at the top and mole per dm cubed at the bottom, so subtract all that malarkey, boom, bang, bosh. I stand corrected. It's just mole per decimeter cubed. My apologies. I think it is anyway. Yeah, it must be because... Yeah, sorry, I'm looking at the bottom and top. So this is top and bottom, it's mole per decimeter cubed, it's not. There we go. So now let's look at question 9ci. Write an expression for the equilibrium constant Kp. So Kp is a bit different, remember. So Kp, so these all must be gases. Otherwise, if it weren't, the question would be a lot more simple. So Kp is equal to products of reactants still, but we have to remember our little p, PCl2 times p, PCl3, all over p of PCl5. Calculate the mole fraction of chlorine present. So mole fraction is the word I call it mole ratio, but you can call it mole fraction as well. So mole fraction is the number of moles of the total in equilibrium. So in this case, it's going to be 0.156 for these two over 0.244 plus 0.156, 2 times 0.156. So 0.156 over 0.244 plus 2 times 0.156 gives me a mole ratio of 0.280 for both chlorine and PCl3. So now what's going to ask for Kp now? So that's the mole fraction of Cl2. Now it's asking for the partial pressure of PCl5. So the partial pressure is where we calculate the mole fraction first and then times it by our total pressure. We told total pressure? We're told our total pressure is 250. So to calculate that, it's going to be 0.244 over 2 times 0.156 plus 0.244 times by the, because mole fraction times total gives us partial. So this means 0.244 over 2 times 0.156 plus 0.244 is equal to 0.439. Oh no, I haven't times it. Times it by the 250 gives us a partial pressure of 109.7, and we are in kilopascals, kPa. So for this one up here, we got 0.280, 0.280 times 250 equals 70. So that means Cl2 partial pressure is 70, and so is the PCl3. It's going to ask us to work out Kp surely now. Calculate the value of Kp and state its units. So this is going to be 70 squared all over 109.7. And this says answer that's going to be just in kilopascals. We get an answer of 44.7 kilopascals. And that is it. That question took a bit longer than I would have hoped for, but there you go. Did I ask it for any significant figures? States units now. So there you go. That is a common KPA question, or KP question.